Assalamualaikum. Hello everyone. Have a nice day for today. In this occasion, we, Umi Mukhayaroh, Rika Setiawati, and Yuliana Maula will present you about analyzing and interpreting quantitative data and also qualitative data. We took two topics from John Creswell in Chapter 6 and Chapter 8. Before we are going to discuss more about those two topics, let's realize that quantitative and qualitative terms are really familiar for us as academic students. Yeah, both qualitative and quantitative are research designs that commonly used by researchers. It is very well known that quantitative data is information about quantities and therefore numbers, while qualitative data is descriptive and regards phenomenon which can be observed but not measured. Then, how to analyze and interpret both of them? Stay tuned here and take your note. Hi, I'm Umi. Let's start this presentation from the steps of analyzing and interpreting quantitative data. There are several interrelated steps used in the process of analyzing quantitative data. The first step is to prepare the data for analysis. This involves determining how to assign numeric scores to the data, assessing the types of scores to use, selecting a statistical program and inputting the data into a program and then cleaning up the database for analysis. The second step begins the data analysis. Typically, you conduct a descriptive analysis of the data reporting measures of central tendency and variation. Then you conduct more sophisticated inferential analysis to test hypotheses and you examine confidence intervals and effect sizes. The next step is to report the result that are found using tables, figures, and a discussion of the key results. Finally, you interpret the results from the data analysis. This consists of summarizing the results, comparing the results with the past literature and theories, advancing the limitation of the study, and ending with suggestion for future research. Let's see the first step. Scoring data. It means that the researcher assigns a numeric score or value to each response category for each question on the instruments used to collect data. For example, assume that parents respond to a survey asking them to indicate their attitudes about choice of a school for children in the school district. One question might be, students should be given an opportunity to select a school of their choice. To analyze the data, you will need to assign scores to response such as 5 means strongly agree, 4 means agree, 3 for undecided, 2 for disagree, and 1 for strongly disagree. Based on these assigned numbers, the parents who checks agree would receive a score of 4. Then, for categorical scales, such as what level do you teach? And the choices are high school, middle school, or elementary, you can arbitrarily assign numbers that make sense, such as 3 for high school, 2 for middle school, and 1 for elementary school. One procedure that can aid you in assigning scores to response is to create a codebook. A codebook is a list of variables or questions that indicates how the researcher will code or score responses from instruments or checklists. An example of a codebook is shown in this figure. Notice that each variable is given a name, for example, grade. A brief definition of the variable, grade level of the students, is given, and numbers are assigned to each response option. For example, 10 for 10th grade, 11 for 11th grade, and 12 for 12th grade. Before conducting an analysis of scores, researchers consider what types of scores to use from their instruments. This is important because the type of score will affect how you enter data into a computer file for analysis. First, single item score is an individual score assigned to each question for each participant in your study. For example, a researcher asked individuals at a local school district meeting, "Will you vote yes or no for the tax levy in the election next Tuesday?" In scoring the data, the researcher would assign a value of 1 to a no response and a value of 2 to a yes response, and have a record of how each individual responded to each question. Second, summed scores. The scores of an individual added over several questions that measure the same variable. For example, the three participants, Jane, Jim, and John, have provided responses to 5 questions. The researcher sums scores for each individual to provide a single score for a variable representing all 5 questions. And then, net or difference scores. It means the scores in a quantitative study that represent a difference or change for each individual. A small change in high scores may be more useful than a larger change in small scores. For example, the small gain in moving from 60 For example, the small gain in moving from 98 to 99 on a 100-point scale may be more meaningful than the large change of going from 46 to 66 on the same scale. This table is the representative of 3 examples that I explained before. It is about single item scores, summed scores, and difference scores. The next step is selecting a statistical program. After scoring the data, researchers select a computer program to analyze their data. Academic researchers generally use statistical programs available as software programs for desktops or laptops, or available on campus computers. And here are some statistical programs that researchers could use. These various online programs useful in simulating statistical concepts for statistical instruction, and the most familiar one is Statistical Package for the Social Science, or SPSS, that usually researchers use to analyze results of simulation models. Inputting the data. Inputting the data occurs when the researcher transfers the data from the responses on instruments to a computer file for analysis. In the column below, there are variables that the researcher is measuring, for example, gender, grade, parents, and so forth. Using the codebook, the researcher assigns a number to each response that reflects a score on each variable. After entering data into the computer grid, you need to determine if there are errors in the data or missing data. Errors occur when participants in your study provide scores outside the range for variables or you input wrong numbers into the data grid. Because these problems may occur, you need to clean the data and decide how to treat missing data. And cleaning the data is the process of inspecting the data for scores or values that are outside the accepted range. For example, participants may provide a 6 for a strongly agree to strongly disagree scale when there are only 5 response options. Alternatively, the researcher might type a score for a participant as 3 for gender, when the only legitimate values are 1 for females and 2 for males. And to examine your database for missing data, you need to assess the database. You have a couple of options to assess the database for missing data. The first, you can eliminate participants with missing scores from the data analysis and include only those participants for which complete data exists. This practice, in effect, may severely reduce the number of overall participants for data analysis. The second one, you can substitute numbers for missing data in the database for individuals. When the variable is categorical, this means substituting a value, such as 9, for all missing values in the data grid. After you prepare and organize the data, you are ready to analyze it. You analyze the data to address each one of your research questions or hypotheses. Then, for analyzing the data, you can conduct descriptive analysis and also inferential analysis. Descriptive analysis or descriptive statistics use the data to provide description of the population either through numerical calculations or graphs or tables. For the purpose of describing properties, it uses measures of central tendency, for example, mean, median, mood, and the measures of dispersion, for example, range, standard deviation, quartile deviation, and variance, etc. Secondly, you can conduct inferential analysis. It allows you to make prediction or inferences from that data. With inferential statistics, you take data from samples and make generalization about a population. And there are two methods of inferential statistics. Those are estimation of parameters and testing of hypotheses. The next step is reporting the results of analyzing data. In reporting the results, the researcher also stays close to the statistical findings without drawing broader implications or meaning from them. Further, this section includes summaries of the data rather than the raw data. For example, the actual scores for individuals. A result section includes tables that summarize statistical information, figures like charts, pictures, drawings that portray variables and the relationship, and the last is detailed explanations about the statistical results. First, table is a summary of quantitative data organized into rows and columns. Typically, tables for reporting results contain quantitative information, but they might contain text information such as summaries of case studies found in the literature or and incorporated earlier in the study before the results. One advantage of using tables is that they can summarize a large amount of data in a small amount of space. Discerning the difference between tables and figures is not always clear-cut. According to APA 2010, a table includes a summary of quantitative data, while a figure presents information in graphs or in visual pictures. Therefore, a figure is a summary of quantitative information presented as a chart, graph, or picture that shows relations among scores or variables. Tables are preferred to figures because tables convey more information in a simple form. APA 2010 also suggests several standards for designing a good figure. And various types of figures are found in educational research studies, like bar charts, depict trends and distribution of data, and scatter plots. It is illustration of the comparison of two different scores and how the scores regress or differ from the mean. And the next types is line graphs. It displays the interaction between two variables in an experiment. And the last types, it is charts that portray the complex relationship among variables in correlational research designs. Now, it's time to present result. In a presentation of results, the researcher presents detailed information about the specific results of the descriptive and inferential statistical analysis. This process requires explaining the central results of each statistical test and presenting this information using language acceptable to quantitative researchers. What represents sufficient information depends on the specific type of test. At the minimum, report whether the hypothesis test was significant or not. Provide important information about the statistical test given the statistics. Include language typically used in reporting statistical results. According to APA 2010, the information about the statistical test, for example, might include a report on degrees of freedom and sample size for the t-square statistic, and means and standard deviations for descriptive statistics. Well, this is the end of my part. For the next material will be presented by my friend, Mbak Rika. Time is yours. Thank you.
Hello everyone, and it is my turn, Rika Setiawati. I'm going to present about interpreting the results of quantitative data. Well, how do you interpret the results of quantitative data? after reporting and explaining the detailed results. Then, in the process of interpreting results, researchers first summarize the major findings and present the broader implications of the research for distinct audiences. Next, explain why the results occurred. After the summary, researchers explain why their results turned out the way they did. Often this explanation is based on returning to prediction made from a theory or conceptual framework that guided the development of research questions or hypotheses. And then advanced limitations. Researchers also advance limitations or weaknesses of their study that may have affected the results. After that, suggest future research. Researchers next advance future research directions based on the results of the present study. Future research directions are suggestions made by the researcher about additional studies that need to be conducted based on the results of the present research.